Good morning, everybody. For today, we're going to have Unit 4, Linear Functions. Specifically, our lesson is all about slope and zeros of a linear function. So let's start. So remember, when we say linear function, it is a function represented by f of x equals mx plus b, where m is the slope and b is the y-intercept in this given. By the way, this is just a review of your grade 8 mathematics. Again, when we say linear function, it is represented by f of x equals mx plus b, where m is our slope and b is our y-intercept. For example, in the function f of x equals 5x minus 1, this is an example of a linear function. How can we tell that it is a linear function? First, we have this symbol, f of x representation. F of x is also equivalent to y. So that means we can also rewrite this function as y equals 5x minus 1. Again, why this is an example of a linear function? Linear in a way that the highest degree or power of x is 1. If you have f of x equals, let's say, x squared minus 7, this is not an example of a linear function because the highest degree of the given function is 2. It's linear if the highest power of x is 1. Now, the slope in the given function is 5. We have 5 here, and the y-intercept is -1. So if you have the operation subtraction, that means that the constant 1 has the sign negative because of the subtraction symbol. So if you have f of x equals, let's say, 3x minus 8, our slope represented by small letter m is the numerical coefficient of x. So yun yung number sa tabi ni x. So we have 3. And our y-intercept represented by small letter b is the constant -8. Now, if you have f of x equals, let's say, negative x over 2 plus 5, our slope here is the numerical coefficient of the first term. When we say numerical coefficient, that is the number beside x. Remember, if it's a fraction and we have here x in the numerator, sir, what's the number beside x? There's 1 here. It is not just written because it's understood that there's 1 there. So the numerical coefficient is -1/2. So that will be our slope. For the y-intercept represented by small letter b, that is a constant in the given function, we have +5. I hope that's clear. Next, slope of a linear function. When we say slope, it is the ratio of the change in vertical distance or rise to the change in horizontal distance or run. So the slope describes the steepness of a line. So it is also called the rate of change. So when we say slope, we are referring to the steepness of a line or the rate of change. So the slope shows how the dependent variable, can you still remember the dependent variable? The dependent variable is y because its value depends on the value of x. So it changes with respect to the independent variable x. So the representation of the slope of a linear function is given by slope equals rise over run. Rise over run. In simple words, let's have the formula. So it is, let's say for example, you have 2 points given. Point 1 with coordinates x sub 1, y sub 1, and point 2 with coordinates x sub 2 and y sub 2. We can solve for the slope of a line using the formula below. So slope equals y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. So here, we will just do simple substitution. Now, if we will be getting a positive slope, that means that the line rises to the right. So positive slope, as we graph, so it rises to the right. A negative slope means that the line falls to the right. So the line falls to the right. So once we graph, and we have this type of graph, that means that the slope is negative. A zero slope means that the line is horizontal. So after graphing the function, say for example, this is the graph. So we know that the slope is 0. Now, when is the time that we will be getting an undefined slope? An undefined slope means that the line is vertical. So after graphing, let's say this is the graph of the function, and you were asked, what is the slope of the given function? Then the answer is undefined because the line is vertical. So we have 4 classifications of slopes. It could be positive, negative, 0, or undefined. Again, the formula, simply subtract y sub 2 and y sub 1 divided by x sub 2 minus x sub 1. Let's have an example. So find the slope of a given line given 2 points, -1, 4, and 2, -5. The first thing that you need to do is to label the coordinates. So we have x sub 1, y sub 1, and x sub 2, y sub 2. And then let's write the formula for the slope. It is given by y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. Let's do substitution. Y sub 2 is -5. Let's write the subtraction symbol. And then y sub 1 is 4. In the denominator, we have x sub 2. What's x sub 2? We have positive 2. And then you write the subtraction symbol. X sub 1 here is -1. So we have -1. Let's simplify. So -5 and -4. -5 minus 4 is -9. In the denominator, remember, if we have minus and then negative, so that means that the denominator will be 2 plus +1. Again, if we are subtracting two integers, we have here the subtraction symbol, and then after the subtraction symbol, we have a negative number. So this will be plus plus already. So that means 2 plus +1. So 2 plus 1 is 3. We will just simplify. So our slope is -3 because -9 divided by +3 is -3. So this is the slope of the function, -3. Now, we also have what we call 0 of a linear function. 0 or zeros that we could have more than one zero. So 0 or zeros of a linear function. It is the value of the variable that makes the function equal to 0. Again, it is the value of the variable that makes the function equal to 0. So we simply equate the function to 0 to solve for the 0 of the linear function. So the 0 of the linear function is also the x-coordinate or the element, the x-coordinate of the x-intercept of its graph. Remember the x-intercept? When we say x-intercept, that means that we have the x value paired with 0. So we have here the x-intercept. So upon reading this statement, the 0 of the linear function is the x-coordinate of the x-intercept. So if you have the x-intercept already, the x-coordinate is also the 0 of the linear function. Let's say, for example, our x-intercept is 5, 0. Therefore, the 0 of the linear function is also the x-coordinate, this coordinate. We will have an example on this. For example, solve for the 0 of the linear function. The linear function given is f of x equals -4 plus 1. Before we proceed, let's have a recall. So when we say slope of the function, it is the numerical coefficient of the term with the variable x. So we have -4. Remember, we have the y-intercept. The y-intercept is the constant term in the given linear function. We have +1. Now, let's solve for the 0. So we can solve for the 0 as we equate the function to 0. So that's why we have let f of x equals 0 as we solve for x. So in this given, the given is f of x equals -4x plus 1. we simply need to equate f of x to 0. So we will just make f of x 0. So 0 equals negative 4x plus 1. And then we will just solve for x. How do we solve for x? So we can simply add 4x on both sides, or the usual thing that you are doing, we are doing transposition. So we will put negative 4x to the left side of the equation. So this will make negative 4x positive, right? Whenever we transpose, we are changing the sign. So 4x positive equals the constant term positive 1. Solving for x means that we don't need 4 there, so we need to divide both sides by 4 to eliminate 4. Therefore, x equals 1/4. So this is the 0 of the function. Now, if this is the 0 of the function, and then you will be asked what is the x-intercept, the x-intercept will be 1/4, 0. Again, this is our x-intercept. Is that clear? This is the 0 of the function, and this is the x-intercept. When we say x-intercept, this is the point. Whenever we plot this point, 1/4, 0, it will be located, or it will be lying on the x-axis. So if we have the graph, if we will plot positive 1/4, 0, if this is 1, dividing 1 by 4, let's say 1, 2, 3, 4, 1/4, 0 is located here. So all x-intercepts can be found on the x-axis. Naintindihan po yun? All x-intercepts, lahat po sila ay makikita sa x-axis because the y element or the y coordinate of the x-intercept is 0. So it will lie always sa x-axis. Next, let's have this example. Find the slope of the line passing through points negative 2, 4, and 3, 1. So same, let's label first x sub 1, y sub 1, x sub 2, y sub 2. We're solving for the slope. You write the formula. Slope equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And then let's do substitution. What is y sub 2? Negative 1. Minus y sub 1 is 4. In the denominator, you copy x sub 2, that's positive 3, minus our x sub 1 is negative 2. So simplifying this will give us negative 5 over, remember, minus negative, this will become positive and positive. So 3 plus 2 is 5. Let's simplify. Negative 5 divided by positive 5 is negative 1. So the slope is negative 1. Next example, given the table of values below, determine the slope and the 0 of the function. So how do we get the slope? Remember, this table of values, in our previous lesson, this can also be rewritten as 1, 9, what else? 2, 7, we have 3, 5, 4, 3, and 5, 1, right? So that means x stands for the domain set of all possible values of x, and f of x, which is also y, this is our range, the set of all possible values of y. Now, we are tasked to solve for the slope. The slope formula, we have m equals y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. So in this case, you just need to choose two ordered pairs. Let's say, for example, we will be choosing the first and the second. So we have x sub 1, y sub 1, x sub 2, and y sub 2, right? So let's do substitution. Our y sub 2 is 7 minus y sub 1 is 9 over x sub 2 is 2 minus x sub 1 is 1. And then let's simplify. 7 minus 9 is negative 2, and 2 minus 1 is 1. Simplifying negative 2 over 1, so that's negative 2. Therefore, our slope is -2. So slope equals -2. Now, oops. So slope is -2. The next thing that we need to do is to solve for the zero. Remember, how do we solve for the zero? We are equating f of x to 0 in order to solve for the value of x, because the value of x is also the zero of the function, right? So we need to have the function, the given function. So remember, our function is represented by y equals mx plus b. We have the slope already, so we have m already. We need to have b, which is the y-intercept, in order for us to form the function. So what is b? B is the coordinate with 0x coordinate, and then this is our y. So if x is 0, what is y? It's just like that. So we need to look for y, because that is also our y-intercept. In this case, there's a pattern here, right? There's a pattern. So 1, 2, 3, 4, 5. And then for the y values, 9, 7, 5, 3, and 1. So if I will put another value of x here, 0, there's a pattern, right? So what is the pattern? The pattern in the domain in y, whenever we subtract from right to left, there's a common difference, -2, right? -2. 3 minus 5, -2. 1 minus 3, -2. Therefore, if we will have 0x here, so there's a pattern here. This must be 11, so that 9 minus 11, -2. So we know that we also have 0 and 11 as part of the coordinates for this given function, 0 and 11. And since we have 0 and 11, we can tell that our y-intercept is 11. Is that clear? May pattern po, tama? So I just inserted 0 kasi we have 1, 2, 3, 4, 5 there already. So, sir, why do we need to have 0? 0 as the value of x? Because we need to look for the y-intercept. What is the reason? We need to form the function because we are solving for the 0. So in solving for the 0 of the function, we need to have the function itself. And to complete the parts of this function, again, we already have the slope, -2, cm. So we also need b, which is the y-intercept. Y-intercept is the coordinate, or you can find the y-intercept in the coordinate with 0 value for the first element. So dapat ang x natin is 0. We will look for its partner for the value of y, and that value of y will be our b. So if x is 0 here, there's a pattern. We got y equals 11. So the y-intercept is 11. Now, it's complete now. We have m, slope, -2, and b, 11. We can now form our function. So y equals mx plus b, right? Our m is -2. We simply change m by -2. We copy x. And then our y-intercept, the constant, is 11. So that's positive. That's why we will put here positive 11. Now that we have this function already, we can now solve for the 0. How do we solve again? We simply need to equate it to 0. So let's make y equivalent to 0. So 0 equals -2x plus 11. Simply transpose -2x to the left side of the equation. So that will make -2x positive 2x now. So 2x equals 11. Dividing both sides by 2, we'll get x equals 11 over 2. So this is the 0 of the function. I hope this is clear. Later on, we're going to have another example, okay? Okay. So there's a note here. If the slope of a linear function is not 0, then the linear function has exactly 1, 0. Again, if the slope after solving, let's say the slope is 5, this is not 0, right? Then the given linear function, let's say for example, the linear function is 5x plus 8. The slope here is 5, right? So the slope is not equal to 0. Then this linear function has exactly 1, 0. So whenever we solve for its value, the value of x, we will just get one value of x. So that is what this statement is saying. The linear function has exactly 1, 0. If you want to check if this is true, equate y to 0, 5x plus 8. So transpose. You can either transpose 5x or positive 8. It's up to you. So for example, you want to transpose the constant term. So we'll have 5x on the right side. The constant term will become negative 8. Divide both sides by 5. So we have here x equals negative 8 over 5. So the slope is not 0. There is exactly 1, 0 for the function. Okay, another set of examples. We're about to be finished. So we have x sub 1, y sub 1, x sub 2, y sub 2. Solve for the slope. How do we do that? You write the formula. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And then you do substitution. X sub 2, negative 8, minus y sub 2 is negative 8, minus y sub 1 is negative 2, divided by x sub 2 is 1, and x sub 1 is negative 5. Remember the process. Whenever we have minus and negative, this will change into positive, positive. Same goes in the denominator. And then let's simplify. Negative 8 plus positive 2 is negative 6. And then we have positive 1 plus positive 5 is 6. Simplify the slope, negative 1. So slope is negative 1. Given the table of values, determine the slope. How do we do that? You choose two ordered pairs. It's up to you. Any ordered pairs. Let's say, for example, you will choose the first two. So we'll have x sub 1. This is our x sub 1. This is our y sub 1, x sub 2, and y sub 2. Let's do substitution in the formula. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Simplify. This will become plus plus. Same goes in the denominator. 2 plus 3 is 5, and negative 1 plus 2 is positive 1, which will give us positive 5 as the slope. So m equals 5. Next, solve for the 0. How do we solve for the 0 again? We need to have the function. Since we have 0 and 7 here, 0, 7, that means we have the y-intercept already. 7. This is our y-intercept. Why do we need y-intercept? Because we need to produce this function, y equals mx plus b. Remember, m is the slope that we solved. So y equals the slope 5. B here is the y-intercept. That is the y value with x value equal to 0. So we have positive 7. If we have this already, to solve for the 0, you simply need to equate y to 0. So 0 equals 5x plus 7. Solve for x. Let us transpose positive 7 to the left side of the equation, making it negative 7. Solving for x, we simply need to divide both sides by 5. Therefore, x is negative 7 over 5. So this is the 0 of the function. Okay. A motorcycle taxi service charges a base fare of 150 pesos and an additional 30 pesos per kilometer. So per kilometer, additional 30 pesos. So for letter A, express the fare function or the fare as the function of the distance traveled. So we need to produce a function, let's say f of d. D stands for the distance traveled. The base fare is 150. And an additional of 30 per kilometer. So we'll have 30x, right? Just like the examples before in the previous lessons. So whenever we add kilometers, so there's an additional 30 per kilometer. So this is for letter A. This is the function for the fare. For letter B, what if the traveling distance is 5 kilometers? That means the distance is 5. How much would be the fare? So that would be 30 multiplied by 5 kilometers plus 150. Simplify. 30 times 150, 30 times 5 is 150 plus the base fare, which is 150. So the fare for traveling 5 kilometers is 300 pesos. For letter C, how many kilometers can a customer travel? For example, you only have 400 pesos. This is the money that you have. The question is how many kilometers can the customer travel with this money? So if we have this function, that means we equate this to 400, and then we will be solving for the kilometers. We will be solving for x. We don't know how many kilometers, but we know that the money is 400 plus 150. And then let's solve for x. Remember, x is the kilometers. It stands or represents the kilometers, the distance. So let us transpose 150 to the left side of the equation, giving us 400 minus 150 equals 30x. 400 minus 150 is 250 equals 30x. And then we simply need to divide both sides by 30. So to cancel out 30 there. Therefore, x equals 250 over 30. Let me write it first here. And then we can simplify this. This is equivalent also to 25 over 3. Or we can simply divide 25 by 3. We're solving for the distance. So 25 divided by 3 is 8.33 or 8 and 1/3, right? So 8.33 kilometers. So the fare for traveling 8.33 kilometers is 400 pesos. So if you have 400 pesos, the customer can travel as far as 8.33 kilometers. Again, a linear function is a function that can be expressed as f of x equals mx plus b, where m is the slope and b is the y-intercept. As we graph any linear function, its graph is a straight line. So whenever you plot the points, all of the points, ordered pairs, you can always get and produce a straight line as the graph of any linear function. The slope of the linear function describes the steepness of the line. It is also the ratio of the change in vertical distance to the change in horizontal distance. Yun yung tinatawag ng rise over run. We have the formula for the slope, y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. When we say 0 of the function, it is the value of the variable that makes the function equal to 0. That's why we are equating f of x to 0 as we solve for the 0 of the function. If you have the x value already, so that is the 0 of the function. This 0 of the function is also the coordinate, x coordinate of the x-intercept. So if this is your x-intercept, this x coordinate is also the 0 of the function. This is just a short glimpse. We will have a short recap of this as we meet tomorrow, or yeah, hopefully tomorrow. So for now, you try to solve the questions that I will be sending in the Quipper app. Okay?